Good morning, class. I know this strange times, strange things are happening right now around the world. Hopefully you're staying safe and healthy. I'm going to provide you guys some different activities and opportunities here to continue your education in just a different format. Just in case you're kind of scared that you're going to be kind of losing it before you head off to college. But again, don't feel obligated. Just consider these as just a different format of just kind of reviewing some previous information we learned throughout the year. Maybe these are things that would definitely help you out in the long run. But again, at the very end, I'll provide you a Google form that you can, again, provide me some feedback and, try out some problems on your own. And I'll get back to you throughout the week to see how you did, see if you need to correct anything. Don't feel obligated to. They're not graded. It's just one of those things I want you to try out some problems to, continue, your learning without learning something new. Just kind of review, because it's always nice to review every now and then. But without further ado, let's jump right in. What you're looking at here is kind of the first part of the activities I want to do is here is kind of a video. Then I'll provide you a Google form at the very end where you can do some problems. But this first topic, the first part that I want to do for our activities this week is just kind of derivatives. Let's start with some basic ones, some ones that we've done in the past. Again, derivative is a fancy word for slope. It's a rate of change. There's two different types of rates of change. There's an average rate of change versus an instantaneous. A derivative is an instantaneous rate of change. So, maybe on a curve you're looking at the exact change at a particular moment on the curve. What the speed is on a curve at that moment that you should be at. But again, the rules we're going to be doing for these over these next couple weeks. The ones I want to focus on today is kind of the power rule and exponential. Those are the big ones. Do we know the basic power rule where you drop the power out front, subtract one off of it, and then can we do exponential rules? Now in these, I will also review some indifference, product, and quotient, and those will be the ones we're really going to focus on later. Those will be some of the last problems. Now, if you're looking at the very bottom of this video, you can see that I have 13 problems kind of picked out that we're going to kind of review. I'm going to try to go through these as fast as I can. Don't feel obligated to watch them all. You can kind of skim through them. Maybe there's a certain problem you didn't understand. You can kind of watch me explain it. Again, you can hit pause. You can try out the problems on your own. But the Google form has different problems in it that you can try. When you hit submit, I'll try to look through them throughout the week, and I'll provide you some feedback individually, what you can do to fix it, if you really want to know if you're doing it right or wrong. Without further ado, let's jump right in. So, first problem I kind of picked out here, it's got, it's a basic sum and difference rule. It's got a plus sign in the middle. So when you do a derivative of this, you just do the derivative of the front, put a plus sign, and then just do the derivative of the back. Now, each of these has their own rule. This is a power rule, normal power rule, drop the power, subtract one off it. And this is what we call an exponential rule. It's where the variable's in the power. That has a different rule. So that's something that I thought we'd kind of need to review. It's one of those things we haven't seen these for a while. That's kind of like the main rule that's kind of this video is all based on today is that particular power rule for exponents. But let's kind of jump in. So we're going to do the first derivative of y, so y prime. When you do this first one, you drop the power up front, and then you subtract 1 off of it. So when I subtract 1 off, it's just a 1 up there. And then the derivative of 2 to the x is the natural log of the base number times the actual object itself. And then you'd have to take it times the derivative of the power that you have. So the derivative of the x in the power is a 1. That's kind of the rule that we do. It's a chain rule. But this is the weird rule that most people always forget. It's how you do the exponential when the power is the variable. It's the natural log of the base times the actual object itself, the exponential, times the derivative of the power. So it's a chain rule. So that's the first problem. That's everything. That's the first derivative. Now, kind of applying this going on, same thing as before. It's almost the exact same problem. I just threw kind of a different twist at it. This part here, you ignore this 4. It's supposed to be done as a product rule. You just ignore it. It's just a leading constant out front. So y prime. So ignore the 4, but we're going to do the 10 the same way we did earlier. So it's the natural log of 10 times the actual exponential, and then times the derivative of the power. And then in the back, we have the minus sign because this is still a sum and difference rule. And then we drop the power out front and subtract 1 off of it. So 3x squared. This is the part most people get confused on. Why we ignore the 4? Because it's a constant. If you want to do it as a product rule, where these two things are being multiplied together, the derivative of 4 is 0, so that would just disappear, and then it'd be plus the next rule, which is this one right here. So Again, it's one of those exponential rules that some people tend to forget. It's something that I thought we should review because it's one of those things we were going to do anyway, going into antiderivatives. Next one, kind of provide you a different one. This one has a different power in it. I'm going to rewrite this problem differently before we start. I'm going to write it like this: theta to the half power. That's half means it means a radical when you put it in a power like that. So when we do the derivative, it's still the natural log of the base times the actual exponential itself, and then you take it times the derivative of the power. In my case, that is half theta negative half, because you're dropping the power out front and then subtracting 1 off the power, and that's where this negative half comes in. So this problem ends up being this, if we actually write it out. It's times 4 to the square root of theta, and then this half and this negative theta will actually end up going to the bottom. So 2, because this 2 goes to the bottom here, and the 1 stays on the top. So this is times 1 up here. The theta goes to the bottom, and it becomes a radical, because that's what a negative half means. It went to the bottom, and it became a radical itself. It's just a different way of writing it. Again, this is just something like going further. It's one of those things like, it's a weird kind of rule. You just have to get used to how they write it. It's one of those things I thought we probably should talk about. We haven't talked about these for a very, very long time. Same thing as before. I picked out a different exponential problem. Still a sum and difference rule. We ignore the 5 out front. It's the natural log of the base times the exponent itself times the power. The derivative of t is just 1. And then the plus sign. We ignore the 6. The natural log of the base times the actual exponential times the derivative of the power. So there you go. Not too difficult on that one. Next one, these are exponentials. When you take the derivative of e, it's still actually the same rules we did before. You do the natural log of the base times the actual exponential itself times the derivative of the power, which in my case is just a 1. The 5 turns out to be a 0, so it doesn't matter. Now this part right here, the natural log of e actually just cancels out and makes 1. So this is actually what this thing ends up being. It ends up being just an ex plus 5, because the 1's out front just multiply together. So that's actually what it ends up being. So that's why the derivative of e is just e itself, because the natural log of e cancels. Same thing as before. Now we're considering a as an actual number. How we know that? This is the variable. X is the variable in this case. So when we do this problem, it's the natural log of a, that's the base, times the actual exponential, times the derivative of the power, which in derivative of 5x is a 5. Now you can move it around, but that's the actual first derivative. This would be f prime of x. Next one, same thing. It's the natural log of the base times the actual exponential times the derivative of the power. So it's a chain rule. Next one, same thing as before. We do power rule, so drop the 2 out front, subtract 1 off of it, so that ends up being a 10x. The derivative of 2 to the x is natural log of the base times the 2 to the x times the 1, and then the derivative of 3 is just 0. So this ends up being this, natural log of 2 times 2 to the x. So there's your answer. Okay, next one, same thing as before. Now we have to actually do the product rule. This is the rule that I said we kind of review earlier. Derivative of it's the derivative of the first times the second plus the derivative of the second times the first. So derivative of the first is 2x times the second plus the derivative of the second, which is this, times the first. And that's, and now if you need to simplify, but that's the basic rule. So derivative of the front times the second plus the derivative of the second times the first. And this is the first item. Again, it's kind of a weird rule once you get to see it. And now notice none of these problems, I haven't picked any cosines and trig functions and sines and anything like that. This is just basic exponentials, power rules. Something that I thought we probably should review first. It's been a long time since we've seen exponentials like this. Same thing as before. This is just a number, so ignore it. The natural log of 4 just stays out front. We just ignore it. That's just a leading number. So the derivative of 4 to the x is natural log of 4. That's the derivative of the base, or the natural log of the base, times the actual exponential times the derivative of the power, the exponential. And again, this thing just stayed there because it was just a constant out front. Okay, next one. Same thing as before. This item right here, I'm just going to rewrite this. This is actually what we're looking at. I know this seems weird, just how it's written. We don't simplify the 3's because the 3 has an x in it and the one on the bottom doesn't. There's different ways of writing it. I've definitely seen this problem written like this, where you can subtract the bases, or subtract the powers, I mean, because that's the rule from Algebra 2, where if you simplify things, you actually subtract the exponents. So this is a different way of writing it, these two, and you can do them differently as derivatives. You can move this to the top and make it x to the negative half, because that's moving it up to the top makes it a negative exponent, and then the half is the actual fraction. So it doesn't really matter how you want to write this. I'm just going to do the basic derivative of it. Some people like this part here. They like this part for the front one. I'm going to do it for this one. I don't know why. It's just the one I'm going to use. Now, doing the derivative here. Derivative of this first part, ignore the 1/3. Derivative of 3 to the x is natural log of the base times the exponent times the derivative of the power. Plus, now the derivative of the second item, which is I drop the power out front. Take it times the front, and then subtract 1 off of it, so it's negative 1 1/2, which is negative 3/2, because I subtract 1 more off of it. So simplifying this all down, because this is getting kind of ugly, natural log of 3 times 3x, and this is all divided by 3, plus, in fact, I'm going to make that a minus sign. Let's make that a minus sign. 33, and on the bottom, I'm going to put a 2 down here, because we're dividing it by 2. But then the x to the negative 3/2 is going down, so this is, it's going down to the bottom because it has a negative power, but it's to the power of 3, and it's a square root. Now, how I know that is because it's 3/2, that's 1.5 x, and so this is the exponent, and this is the radical that's on it. But it's moved to the bottom. So that's kind of the idea. And that would be the answer for that. Again, there's different ways of writing it. I just thought this was kind of a different way. All right. We got 2 problems left here. So in this one, same rules before. We ignore the 2. Derivative of e to the x is natural log of e times the actual exponent times the derivative of the power in the exponent, and then the power rule to x to the first. And again, this would cancel out, making 1. So it ends up being 2e to the x plus 2x. All right, and the last one, quotient rule. I did promise you we'd do one quotient rule. So derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. And that would be the answer on that one. Okay, this is just one of those things I wanted you to get an opportunity to kind of review some of the stuff we've done previously. Again, I know I went really fast through those. If you need to watch any of those particular problems over again, or maybe I made a mistake, you can go back and kind of look at it and see it. Maybe you can figure out a different way of doing it. I have a Google form that I provided to you. I'm sending an email about it. You can try out a couple of those problems, see if you can do any of them. If you want feedback on it, I'll gladly go through the Google form answers that you provided me, and I'll see how you did it. I know it's going to be kind of tough to type it in there, so do the best you can. Maybe you can use parentheses and type on your keyboard and see what answer you've submitted. If you want to maybe type it on an email or something, you can do that. But I'd be interested to see kind of how you did on some of that Google problems on the Google form. Stay safe, stay healthy, and hopefully see you later.